All right, so returning to the halving, yeah, so absolutely. What it does is it's used, so you've got some select, this is your projection, probably with some aggregation in it if you'd like. From your table, you're going to group it by this column or columns. And what this halving clause is all about is maybe I don't want some of the groups that I've formed. Maybe I want to throw out. I only want groups of users who have scores greater than 80 or something. Okay, so I could take some aggregate, you know, and I could take like who have an average score, you know, that's greater than 60, all the students who are going to graduate. So aggregate score, and this would be then my operation greater than, you know, 60 or something. Let's say if I was grouping by students again and scores, all those other ones, they wouldn't be included in the result set where I've gone and done it. So it's a way of throwing out groups that you don't want in the group by. All right, so that's nice, yes. Although I have to say it's not something obviously I've done that commonly because I obviously blanked on exactly why we have it. Now, there is this more complex functionality with doing what are known as nested subqueries. But it is quite handy. So even if it is a bit on the more complex side, it is handy. And sometimes it can just be such a nice way to solve problems. And with these, one of the first ways we use nested subqueries is with using the statements in and not in. And so an example here is we can do, again, our select with our projection from whatever tables we have, where we're going to have something, we'll just say X at the moment, in, and then we are going to put another select statement, a subquery here. Again, we can have a select blah from blah where blah. Now this needs to be a single column. Okay, so we're going to select a single column. This whole thing over here, the idea is it produces a set of values. So we're going to pick some column that comes from our expression of this table, and then we're going to have all those values in a set. So we've got this set sitting here now, and so what we have really happening is we're going to select from a relation the rows where some column X, so some column is found, its value is found in this set. And so these might be, you know, something that we've selected carefully, like, oh, these are the high value customers. And so these are customer IDs, and we've got a calculation in here to get those high value customers. And then what we're doing here is now this is a separate query. Maybe we're trying to find out something about products that are purchased by high value customers. And I only wanted to do that then for the customers who have their ID is in this set. It's a really neat way to basically, you can have these complex requirements. So it's basically like, this would be like customer ID. And my complex requirement was, oh, these are the high value. This is how I calculate a high value customer, and I know how to calculate that and find those people. I don't know how to do it as one gigantic join. What I can do is I can do this, obtain that set of people, have that there, and this then will go through and check, ooh, is this like customer ID in that set? Yes. If so, that becomes in the result set here. If no, it's one of the excluded. So not in means you're not found in that set. All right, super handy. There are much less used things such as sum and all. Sum is about saying, testing some comparison usually that compared to any of these you're greater. All is you're greater than all of them or something along those lines. See the book, you know. I could go into them in more detail, but they're quite rarely used actually. There's one that's probably a little bit more used than sum and all is exists. This is used, this will be true if some tuples in a result set. So again, you got some subquery and you're going to do something and say, oh yeah, is there anything in this subquery? If so, then it's true to be the case. I don't think I've ever used it, but again, these are some of the smaller points of the language. In and not in, I guarantee you'll go, I want to use those. Very common. Some, all, and exists are less common, but you should know that they're around so that if you're like, there's got to be a way to solve this problem. Yeah, you know they're part of the toolkit that you have. Another way that we have subqueries that is really cool are when we do subqueries in the from clause. And this can be super handy. So we go select what our projection is from. Now, normally what we're doing here is we're putting a relation, or we're putting several tables there to do the cross product. No matter what, basically what select says is, yeah, I'm going to go and work from, you've got some relation here, and then I'll have my predicate and other things, and this is my projection. Well, what if we don't have a table already, or a set of tables that we want to do the cross product on, but we know that we have another query that we could issue, and again, queries produce relations. All right, so when we run, it's just like the relational algebra. We do all these methods, and the end result is another relation. Well, in like relational algebra, we are able to do something, produce a relation, then send it to another function, produce another relation, and so on. We can do the same thing here. So we can absolutely go and stick a select statement in here where we go, you know, select whatever, our projection, you know, blah, 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 from where. So you can put a whole select statement in there. That select statement produces for you a relation. So you can query from the relation that you've computed on the fly there. You're going to want to be able to refer to it in the where and in the projection. So you can attach a name to this via the rename operator as. So you can give some name to it so that whatever, you know, you can refer to the resulting columns in that relation with name dot whatever. Likewise, in your where clause, you can reference the name that you have here in its columns. Very handy. So again, this just lets you compute that relation on the fly and then select from that relation that you've computed. All right, set of really big important operations methods in SQL now. So we've seen a lot about how to query. And in fact, I would say a gigantic amount of SQL is all about how can I compute something via this language and find the resulting set out of the data. But sometimes we want to get rid of data. And for that, we need to delete. All right. So the basic structure of a delete is delete from There is no projection because we're just getting rid of stuff. We're not going to show you anything. You've got your table name, okay, where, and this is your predicate. So you've got some predicate in here. You've got your single table that you're going to delete from there. And the idea is that this will then delete, it's going to remove all the rows from the table that match or meet the requirements of the predicate. All right, very simple. A huge warning before you make this mistake. It is a terrible tragedy usually when you do delete from, boom, your table. Okay, this deletes all rows. You are not going to get are you sure you want to delete all the rows in your database table? You hit enter, they're all gone. It hurts. Same thing with this delete, by the way. This delete doesn't ask you either. It doesn't say, oh, I'm going to delete the following things. Take a look at them. Is that really what you want to delete? Absolutely not. Welcome to being the software engineer, the software developer here. You have hardcore control over this system. You're not some end user who needs to be pampered. You know what you're doing. You're like the Jedi, the ninja, whatever. You decide to delete things, they are deleted. With great power comes great responsibility. So, you need to learn. One of the biggest things that I believe that you do here before you do something like this is first test with a select. If you have any doubts, so again, you could be select star from and do this. So you do a select star from table where you've got your predicate, okay? You, as the user, as the power user, I want to see what it is that I'm about to delete. Is that really what I wanted to delete? So you can take the same from where predicate, put a select star on it, and see what those rows are. And you're like, yeah, those are the ones I wanted to delete. I'm going to do this right. And then you go and you replace the select star with your delete. And you hit enter. And you just say your prayers and you move on. Okay. All right. Next up, let's put data into the database. We use an insert for that. The basic structure is the following. I will admit to you that every time I want to write an insert statement, I turn to Google and I write SQL insert, and I go get the doggone syntax for it. I don't know why I can't ever remember it. But it is not that hard. The idea basically is what we're going to do is we're going to add to whatever our table is. So this is a table name. And we're going to specify that we're going to add the following columns. Again, some columns, we haven't talked about this really, but some columns have a default value available to them. So, or they might allow nulls. So if a column allows nulls, heaven help you, if they allow nulls, you don't have to actually insert a value. A null will be put into that table for you. So you wouldn't have to specify those columns if you wanted them to be null. Likewise, there are columns that contain default values, and you don't need to specify them. If you don't specify those columns, they'll get their default value. The most common place that we end up with the default values is when we have a column that has an auto-incremented value on it, such as an ID. And this will be prevalent all through our work in Rails. Most of the tables that we'll deal with have an auto increment ID on them. So that means that every time we insert something new, we get the next ID in a sequence, and then the next ID and the next ID. Every time we do an insert, we never need to try to figure out what is the right ID to give this new row. No, the database will keep track and say, oh, the next one is 62, and then the next one is 63, and it keeps track of them. And as things are inserted, they get a new unique ID from a sequence of IDs. Very handy. If you were to specify that ID as one of the columns, you would override that default auto-incremented value, and you don't really want to do that. That would be special circumstances. So you're going to often see a situation where, let's say we've got a users table, users, and again, let's say we have an ID and we have a name, and we already have, like one, and Mark is in that table. All right. And let's say this guy I have set up, I've created the table to auto increment the ID column, and it's my primary key. So the name, I might change my name and stuff like that, but my user ID shouldn't ever change. So we could definitely have an insert statement that's insert into users, and I'm going to put in the name. I don't think I actually have to quote that because it's a column, but then it's values, and I'm going to put in both Mark and Mary. All right. So I'm not specifying the ID as one of the columns. I'm only specifying name as the column, and the value for name is going to be Mary. So when this insert runs, this with an auto increment, and it knows the last value was a 1, then 2 is added, and Mary is added to the table as the next user. Super handy, super neat. All right. Finally, super important thing is the ability to change the data in a database. Again, we keep talking about adding money to bank accounts, removing money. We obviously will want to be able to update values for a lot of systems. So update. So you write an again, I'll also tell you, update is something every single time I want to do it, I go query to look up the syntax. I don't know why I haven't ever memorized the syntax. So we update the table, and we set whatever the column name is here. So we set our column equal to some value, whatever their value X is, and we need to pick out that row or rows where we want this to happen. So this is a predicate. So we need some predicate in here. And this is going to, determine which rows of the table are updated. So we can change this column for those rows that we've selected from this table to have this value. And you can do things absolutely where you can do math where you can set this column equal to the column times 1.1 or something. So, I've increased all the values by 10%. Or I've done some function on this and I've added a string or prepended and all sorts of stuff. I think it's most common just to, what your goal usually is, and you're going to see this lots, is we have these database tables. Again, take users. You know, you're going to have users with an ID and a name, and we're going to have a unique ID for each user, Mark and Mary. So let's say I decide to change my name to Fred. And so we could update users, set name equal to Fred, where, and the common thing is going to be, I will know the ID of the user I want to update, where ID equals 1 will be my predicate, and then, oh yeah, I'll change user 1's name. So usually our goal is to find the one row that we want to change. Occasionally, we have some set of sweeping changes that we want to make to a database, and then we might have select many more rows. But it's most common to select one row, and I would say it's most common to select that one row by, we already know a unique primary key for it, and we're going to identify that row with that primary key there. All right, so that basically means now, you may have heard this acronym before, CRUD. We have covered CRUD now. So CRUD operations, pretty sensible. We know how to create data. So we can insert it, or sticking things in the data. Then we can use it. We can read that data. This is when we write our select statements. We can update that data. We get to use an update method, update call for that. And we can get rid of it. We can delete or destroy. And again, you've got your delete. So you'll see people talk about, oh, I've written an application. It's a CRUD application. It means primarily I'm talking with a database, and I've given the user functionality to create, read, update, and delete. And I have that all built in to operate over the key sets of data in the system. Largely, people are wanting to put stuff in, read it, operate it, change it, delete it. That's the nature of a ton of our databases. So being able to support CRUD means you've got a full set of tools at your, you're ready to go. You're ready to handle them. Okay, we've covered chapter 3. Again, there are some details that you'll see in the reading. We did not cover creating tables. It's largely just reading the syntax. You can also, I know that when we get to Rails, we're going to use a different methodology for creating tables. So I'm not that interested in you spending tons of time learning the syntax of the create statements, because you're going to learn another syntax for that anyways. And the concepts of creating tables is not hard, other than we often, again, want to be able to put in constraints. What is our primary key? What should not be null? What are our foreign key constraints? And there is another constraint notion that we haven't talked about, is, for example, not allowing duplicate values of certain columns and so forth. And we can implement those as well. We implement those by applying an index, and that index has to be unique. Anyways, we're going to see that later. There's a lot in the SQL language. There's a whole 2 more chapters in the database book. We're going to dig into chapter 4 coming up. Let us do some fancier joins. Primarily is the part there. I highly advise to help you get through learning SQL is to pick up again that Headfirst SQL book. By pick up, I mean access it via our university library. That takes you to O'Reilly, and you can read through it, and you're gonna see a lot more of the nitty-gritty, but the practical nitty-gritty, not esoteric nitty-gritty. So again, that's a book like Headfirst SQL is the one that it's like, I need to cram for my interview where I'm going to be a database person at a company. not the database person, but I need to be sure I know enough to make it through the interview, and then I'll have that book beside me as I work on the job to create all my queries and stuff. All right, that's the end of the introduction to SQL.